Okay, here are our notes on energy. Make sure that you have the worksheet that goes with it so you can fill in the missing words. Okay, work is the transfer of energy, okay, from one place to another. Work is done when a force moves another object. So anytime that you push on something, you are applying work. You are doing work when you are moving the object. As long as the object moves, you are doing work. When work is being done on an object, the object gains energy. Okay, so if you're pushing a box across the floor, that box gains energy because you are pushing on it. Energy is the ability to do work or cause change. Energy is measured in joules. Joules is used for a unit for energy and also for work. They have the same unit. Power is the rate at which work is done. Power is the rate at which energy is transferred in a single unit of time. The equation to calculate power is the amount of energy transferred over time. There are two different kinds of energy. There's potential energy and kinetic energy. Potential energy, all energy is either potential energy or kinetic energy. Okay? Kinetic energy is when it's in motion. Potential energy is when it's stored and waiting to be used. There are three other types of potential energy: gravitational potential energy, elastic potential energy, and chemical potential energy. Okay? Chemical potential energy is like in a battery. Elastic potential energy is like when you pull back a rubber band right before you shoot it. That stretch is called elastic potential energy. And then gravitational potential energy has to do with the height of an object. We're going to focus on gravitational potential energy, and kinetic energy. Potential energy is the energy that is stored and waiting to be used later. Potential energy results from the shape or position of an object. Okay, an object, what that means is that an object that's round has more potential to roll than an object that's square. Okay, if you have a block sitting on the floor, it's going to have less potential energy than a ball sitting on the floor because a ball can roll. Gravitational potential energy is energy due to the object's position. Okay, we see this piece of dirt has gravitational potential energy because it could fall. Okay, it's up at a height. To calculate gravitational potential energy, you're always looking at the mass and the height. Those are the two variables for gravitational potential energy, the mass and the height. So if you have two people that are the same mass climbing up a rock wall, the one that's higher on the wall is going to have greater amount of potential energy. And that was a reference to the reading in your book. Okay, but if you have someone that is at the same height and one of them has a greater mass, the person with the greater mass is going to have the greater potential energy, even though they're at the same height. Another example here of gravitational potential energy is that dog. He has more gravitational potential energy than the man because he's up higher, okay, even if they're the same mass. Kinetic energy, abbreviated KE. Kinetic energy is the energy an object has to do to its motion. Kinetic energy is the energy an object has due to its motion. So when something's moving, it has kinetic energy. So when you change an object's speed, it has a greater effect on its kinetic energy. What that means is that the faster something goes, it's going to have greater kinetic energy. Even if it has a smaller mass than something that's traveled slower, it's going to end up having the greater kinetic energy. And here's the equation to calculate kinetic energy. Half times the mass times speed squared. We're not going to be using this equation, but that is the equation to calculate kinetic energy. Okay, so here we have a roller coaster, and if we look at it, right here is where it has the most potential energy. You see the bars all the way filled up. And on this one, it's a skier on a slope. He starts up here with the most potential energy, and then as he gradually goes down the hill, his kinetic energy increases. And then as he slows down, at the bottom, potential energy increases and kinetic energy decreases. So at the top of the hill, he has the most potential energy. At the bottom of the hill, he would have the most kinetic energy, right before the potential energy starts taking back over. Okay, make sure that you fill out those notes and let me know if you have any questions.